Hi Year 12, so I know a lot of you are still struggling with EZ Isomerism, so I thought I'd just make a very quick video to go through it for those of you that need the extra support. So I've drawn the smallest alkene, which is ethene. Attached to those carbons that are in the double bond are 4 different substituent groups. In this case, we have 4 sets of hydrogen. The way to work out if an alkene has EZ isomerism is to determine about whether there are priority groups attached to the carbon-to-carbon double bond. So if I draw but-2-ene, attached to the carbons in this carbon-to-carbon bond is a CH3, a hydrogen, and another CH3. Let's look at one side at a time. So over here we have a CH3 that has a total atomic number of 9 because carbon is 6 and I've got 3 sets of hydrogen, so I've got a total atomic number of 9. Over here the atomic number, well, I only have hydrogen, so my atomic number is 1. The greater the atomic number, the higher the priority. So if CH3 has got a higher atomic number than hydrogen, that makes CH3 my priority group. If we now flick over and have a look at the other side, well, I've got a hydrogen again, and I've got another CH3. The total atomic number of this CH3 is 9. The total atomic number of this hydrogen is 1. As a result, the CH3 is once again the higher priority in comparison to the hydrogen. Now if we have a look at where those priority groups are, they are on opposite sides. They are on opposite sides of the carbon-to-carbon double bond. If they are on opposite sides of the carbon-to-carbon double bond, that makes that E isomerism. If we draw this again, I've got the carbon-to-carbon double bond, CH3, H, but switch this round, we've got CH3 being my highest priority group on this side. We then have CH3 over here being my highest priority group on the left-hand side. Those CH3s are on the same side of the double bond. And if they're on the same side of the double bond, it is Z isomerism. Easy way to remember it, if they're on the same side, it is Z isomerism. If we look at a completely different example, if we've got a double bond, we've got a Cl, a CH3, an H, and let's say a Br, let's try and work out which one has the highest priority and whether this is going to be E or Z isomerism. Attached to this carbon, we've got a hydrogen and we've got a Br. The atomic number for H is 1. The atomic number for Br, oh god, this is going off the top of my head, I think is 35. But actually, let me very quickly check a periodic table to check I'm telling you the correct thing. Give me a moment. Br, yes, it's 35. We've then got, as a result, the Br, it has a higher atomic number, meaning that it has a higher priority. So as a result, the Br is the higher priority. Switch to the other side. We've got a Cl and a CH3. A Cl has an atomic number of 17.5 and 17, sorry, and CH3 has an atomic number of 9. As a result, the Cl becomes the higher priority because it's got a higher atomic number. We've got a Br here and a Cl over here as the highest priorities. They are on opposite sides of the carbon-to-carbon bond, so what you have is E isomerism because they're on opposite sides. Now if we go all the way back, it's going to take some time. I will get better at this year 12. Just need enough space to draw one more. Right. If you now had something that looked like this, got hydrogen, CH3, CH3, and CH3. On this side, we have a hydrogen, we have a CH3. We've got an atomic number of 1, we have a total atomic number of 9. The CH3 is the higher priority because it has a higher atomic number, and it's on this side. If we now switch over to the left-hand side, we've got a CH3 and a CH3. We've got an atomic number of 9 and another atomic number of 9. If they have the same total atomic number, there can't be a difference in priority. And if there isn't a difference in priority, that means there is no EZ isomerism. Yeah? I hope that makes sense, year 12. If you have any other questions, please do let me know.